Hello everyone, welcome to Coders Camp. We are at 16th day of June LeetCode challenge, and the problem we are going to cover in this video is generate parentheses. So the input given here is an integer number and we have to return the list of parentheses or well-formed parentheses for the given number. So let's understand this problem with an example. So consider this where n is equal to 1, there is a one well-formed parenthesis with one open bracket and one closed bracket. So this is said to be a well-formed parenthesis. Same way, if n is equal to 2, this is the first format where all the brackets are within everything and two separate well-formed brackets. Same way, when n is equal to 3, all the brackets are within itself, three separate brackets, and you understand the pattern. And it goes like this. So first naive approach is going to be, we generate all possible string of length n into 2 because we should have one closed parenthesis and equal number of open parentheses before that. So if there is a n is equal to 1, then the string length must be 2. So we form all possible combination of strings with parenthesis of length n is equal to 2 and validate each parenthesis set whether it is valid or not. So for example, if n is equal to 1, we can form either this or this as the set of list of possible parentheses, and we put this into a method is valid and check whether it is a valid form or not. And then whichever is the valid ones, we'll add that to our list. So this is gonna take exponential time, that is 2 power n time, as we are going to find all possible strings first and then filter them out based on the validity. So how do we approach this in an optimal way? So before getting into the algorithm technique, let's understand what is the intuition behind this problem. So they have given n as an input. Let's take 3 for our example, and we are going to form the brackets or well-formed parentheses of length n into 2, which is nothing but 6. So now what are the possible ways we can construct or graft our output? So how do we define the rules or constraints to construct our string? So the first rule is, as we know, it should be of length n into 2. And the second rule is, you must have an open bracket in order to have a closed bracket. So whenever you take a decision to put an open bracket or a closed bracket, you can decide based on the number of open brackets present in the string. So if there is no open bracket present, then you don't or you cannot fill a closed bracket. Same way, the first character must always be an open bracket. So yes, based on these constraints, let's start constructing our string. So as I said, if our n is equal to 3, then in that case, we must have 3 open brackets followed by 3 closed bracket. So now let's start by having all threes. So let's short it down to two possibilities. That is, the first character can be an open bracket or a closed bracket. In this case, if you put an open bracket, then the number of open brackets will be moved to 2 and the number of closed brackets is still the same. So your string is going to look something like this. Same way, if you are trying to put a closed bracket, then number of open brackets is going to be 3 and number of closed brackets are going to be 2, and your string is going to look something like this and it is invalid. So you cannot further proceed with it and start proceeding with the next one. So here we have 2 open bracket options left and 3 closed bracket options left. So from here you can either choose to put an open bracket next or a closed bracket next. So in that case, your number of open brackets is going to become 1 and closed brackets are going to become 3. And in the second case, your number of open brackets are going to be the same as 2 and number of closed brackets are going to be becoming 2, as we are going to put a closed bracket here. Then your strings are going to look something like this. So from here, you can further shorten yours to put a closed bracket from this state or put an open bracket from this state. Then you'll have your crafted strings like this. That is, here you have filled all your 3 open brackets and you don't have any other open brackets to fill. So all you can do to the rest of the string is fill the closed brackets, whichever is left. So this string is going to form a well-formed bracket, that is 3 open and 3 closed is rest, and this is going to form one valid well parenthesis. Coming to our next formed string, which is having two open brackets and one closed brackets, and still have one open bracket and two closed bracket left. So from this stage, you can decide either to put one more open bracket or one more closed bracket, and then further it proceeds from this states. Same way it is going to proceed from all other states, and whenever it meets the length of 6, then it is going to stop and add that string to our result. As we are not going to proceed with invalid strings further, we are not going to get our invalid strings at the end. So we are going to proceed only with the possible valid ones. So once it is ended with 0, 0, then we are going to append or add this string to our result. So this is the overall idea behind this solution, and this is going to work a basic DFS where it goes deep exploring all possible valid ones, and where the backtracking comes here is we are not going to proceed further with the invalid ones. For example, we are left with this string at the state where we have two open brackets left to fill and one closed bracket left to fill, which is actually an invalid scenario where we need a open bracket in order to use this closed bracket. So we are not further going to proceed with this path and skip this path and further proceed with the valid ones. So this is how this backtracking algorithm is going to work. And talking about the time and space complexity is pretty simple. As we need to form the string of length n into 2, we are going to use big O of n space to construct our valid strings. But talking about the time complexity, we are going to explore all possible brackets and skip the invalid ones. So overall, it is said to be that it is going to work in the form of Catalan number, which is nothing but 2n factorial by n plus 1 factorial into n plus 1 factorial, and this can be asymptotically represented as 4 power n into n. So I'm not sure about how exactly this Catalan number works. Please do comment below and have a healthy discussion over the comment section. Let me also learn from you. So if you are very familiar with how to calculate this time complexity, do comment below and let me and others learn. So let's go to the code now. So first we need to return our output in the form of list. So let us declare a result list and call our backtrack method and return our list. So these parameters are nothing but this is the string we are going to construct, and these are the count of number of open brackets and number of closed brackets and the maximum number of length of the string we need to form. So here let us write our backtrack method. So here we are checking if our formed string length is equal to length into 2, then in that case we are going to add that to our list. If not, we are going to construct our string with open and closed brackets. So here we have the count starting with 0, 0, and we are going to fill our open and closed brackets to the size of length because it has to have n open and n closed brackets. So first we are checking if open is less than length. So it is nothing but we have to start our parenthesis always with the open bracket. So we are going to start with open bracket. Then we are going to call the same function recursively with the list and the string having an open bracket. And if we add one open bracket, then the count of open bracket becomes plus 1 and the closed bracket is going to be same. Same way we are going to check if our closed bracket is less than length. Then again we are going to call the same backtrack function recursively with adding an extra closed bracket. This is going to call recursively again and again to construct our open brackets, and then comes the close bracket. So hope you're understanding this approach. Let's run and try. So yes, let's submit. So yes, the solution is accepted and runs in 1 millisecond. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and don't forget to comment about the time complexity. Thank you.